Okay, hello, hola, shalom. I'm actually Israeli, so shalom is like my. Okay, so this is going to be the first kind of example, coding example. Again, I'm basing a lot of this class on what Alberto has shared with me from his prior sessions, and hopefully this lines up with what he's doing on campus as well. Please give me feedback on what's working, what's not working, especially with what I'm about to do. It's going to be a relatively lengthy, in-depth kind of coding example. And so let's get started. There's an exercise online for you to kind of set up a configuration environment, but I'll do a little bit of that in this, and hopefully that'll help you. There's like 20,000 different ways to set up a project, create a build system. Don't, you know, generally speaking, like memorizing this stuff isn't great because there's a lot of different ways you can kind of figure it out. So just understanding the basics of it is really more important. But let me kind of run you through it. So, okay, first off, the version of Visual Studio for this class we're going to use is 2019. So to get 2019, you can download. Let me create a new folder here, a new tab here. So all you have to do is say Visual Studio or download, and your first guy will be. There you go. You can download the community. Professional costs money, so I don't really recommend it. I also highly recommend you download Visual Studio Code. It's a lighter weight editor. Visual Studio tends to take like 5 million years to load, so Code is a great way to go through your stuff really quickly and mess around. Great. So assuming that you do that, you're going to download it, and you're going to get the installer. This is what the installer looks like after you've installed the application. So you can have multiple versions of Visual Studio on your computer. You can modify them, you can update them. When you go through the process, you'll be able to really kind of know what's going on. Let me quickly disable the sounds for general. I'm not trying to ignore you guys on general, but while I'm streaming to a particular class, I'll only leave that particular class unmuted. Otherwise, the video will be full of boop, 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 boop all the time, and I think that's not going to be good for anyone. Great. So you can actually use the installer to launch, but I prefer to just get it from my computer. So I'm not going to show you how to set up a solution from scratch, but if you really want to, know that, I think that's in the exercise. So if you have any questions about this, let me know. But I will show you how to effectively create a project within a solution, and I'm going to start everything from the ground up. So in this lecture, we're going to go and really tackle setting up an initial OpenGL initialization, and also getting everything to work, and getting to a point where we can then render a triangle onto the screen. So let's go ahead and open this with Visual Studio 2019. Great. And now you can see I already have the project set up here, but let's create a new solution. And to do that, all you have to do is you can go here and you can say add. And you can actually create a, no, that's not what I want. I want a new project. So how do we add a new project? Right here. Add a, okay, fine. It is add a new item. Jerks. No, it's not. All right, welcome to here we go, right. There we go. You have to click on the solution thing, add new project. Cool. So we're going to start off with a empty project. You can start off with a console app, but it's better to start off with an empty object, and I'll kind of explain how to get to the point where you can then load up OpenGL and get everything working. So let's go. Let's make sure I'm in the right place. I'm in the right place. This is the folder that my top level solution is in. And I can call this OpenGL example done. Great. Create. Nice. You'll notice that now this is here and it's empty. So if I build it, it will build because there's nothing in it. So if I run it, however, you'll see the final project actually run. So why is that? And the reason is that this is not set. This is set as the startup object. So if you right click on this and then you say set as startup project, now if I run, nothing will happen because there is no executable. So to kick us off, what we want to do is we want to create a new item. And we're just going to call this main.cpp. Cool. And that's all we really have to do. Although it's probably good hygiene to first start and create our main.h file. And the main.h file is going to include all of the includes and things like that that we want, and potentially even objects. And so this is a really generally good practice right here, is what's called the sort of blocker. You want to make sure that this file only gets included one time. So what happens here is if this particular file is included again, and this will get defined, once you load it, once you include it the first time, if it finds that particular symbol in the project, then it won't include what's in here, right? And you'll notice that I'm like, okay, int a equals 5, that code is live right now. If I want to instead define main.h, this will go gray because it's already been defined. So, fun little hack. There's also a thing that's Windows specific called pragma once. Oops. If you want to use that. But this is cross-platform and child-proof. So what we're going to do is we're going to include a couple of things. We're going to include IOStream. We're going to include stdio. We're going to include Windows. Great. And that's it for now. Oh, so there's another file, and I'm going to talk about this in a little bit. So let's leave that alone. I'll add it later. And now if we go into main, we'll do include main.h. And let's start off with a standard C-style main function. Sorry, I'm missing keys on the keyboard because I'm not sitting the right way. Oops. Great. And let's do a little printf hello world. Great. Let's build it. And great, a lot of garbage code. And let's, cool. So hello world, but it's in the same line. Why did that happen? That's because we didn't give it a little character guy, which I think I got wrong. No, great. But hello world. So this is, now you got some code, it's working. Why is that pause there? Because now I have this press any key to continue. Now you can see this thing that pops up, so I'm kind of like doubling down. But what's nice about this is if I move to the release, it will still give me that press any key to continue. But let's stay in debug for now. Cool. So Now we've got a basic thing, and we need to kind of talk a little bit about what is it that we need to do to actually start to show stuff on the screen. So per the previous lecture, first off, let's add a little thing here. That just tells us that our thing is working. And let's kind of make notes about what we have to do. We have to initialize the window. And let's create regions. And this is nice because when you actually you can actually use these regions to sort of create almost like an outline of your project, and that's pretty fun. Let's see if he knows how to type region. By the way, fun fact, you are able to indent preprocessor macros. I know, it's crazy, but do it. It's so much nicer. You'll notice that when I'm coding, I'm seeing a lot of things popping up and wacky. A lot of it's sort of just second nature to me. And I'm also using a plugin that I highly, highly recommend called Visual Assist X. It's $50 if you're a student. It's money well spent. $50 a year, and you don't really need to update it unless you want to. What else do we need to do? We also need to We also need to initialize OpenGL. Great, Hebrew. And we also need to compile our shaders. So like we were talking about in the lectures before, shaders are actual applications that are running on the GPU, and so you do have to compile them. True story. I'm not sure why that built. So I'm a little bit of a keyboard nerd. You may hear I have a DAS key here. It's quite loud. It's like Cherry Brown's. I've got way louder keys if you want me to. I have a real force over there. But this one I'm always a bit clumsy on, so I apologize. The next thing we have to do is we also have to kind of configure our geometry and actually give our application something to render. And then finally, we need to have some kind of event loop or game loop. Let's call it just event loop. Great, and this won't do anything. This will just be just like before, starting, press any key. Where's the any key? Cool. So let's start filling this out. So what do we need to do? Well, right now, this is what's called a console application. And so when Visual Studio sees this line, it sees a C-style thing. You can also see here, if I open up in my properties, this is an application, but where's the actual... Right here, you can see the subsystem is set to console. And you can choose Windows. And if I choose Windows, which is what I want, because I want a window to pop up, and I run it, it's going to yell at me. It's going to be like, no, I don't want to run your shit. Do not show this again. No, I do not want you to run a failed build. If I go to the errors, it's going to say, unresolved external symbol, win main. So when you have a Windows subsystem, it expects you to have a win main. So what does a win main look like? It looks like win API, well, you can call this whatever you want, but let's just call it win main. H instance, which is a handle. An H in Windows and Microsoft land means a handle. I should know this. I worked there for a little while. Why they chose handle and not pointer, which is all that it is. will always escape me. Okay, so what's all this crap that I just put in? So this is the instance of your actual application. This is the previous instance that maybe called your application. This is usually null. This is the command line that's passed into the application. It's just a string. LPW means long pointer to a wide string. If you go to the definition, you can kind of see it's a wchar. What's a wchar? It's a wchar-t. So Microsoft loves to throw you for a loop with regards to what everything is. And the end command show, I'm not entirely sure what that does. I think that it determines whether or not to show the window. And these are all things that you get from the underlying OS. So when your application runs, a way to kind of mess with this, by the way, is, so if I run this now, it will fail because WinMain cannot be overloaded. So I guess I need to do that. And great, now I have exactly what I had before, except my output doesn't go here, although I should be able to find it somewhere. Guess not. So where'd it go? Well, we'll talk about it. One thing that we can do is first we need to get that console back. So to do that, let's call this part of our initialization. The reason we want the console is we want to have all that output. There is a way to send data to the Windows output, but that's specific to Windows, and you don't want to do that unless you really have to. The function that you want is what's called alloc console, and this will allocate a console, and if it fails, it'll return false, which you don't want to necessarily deal with right now, and so we'll pretend like it's okay. And then we'll create a file stream for the console, and then we can open the standard streams this way. Oops. Now a lot of this you can look up on the standard stuff, like on the MSVC docs. I can kind of show you how that goes. I don't know any of this stuff. The way you would want to look up how to do it is you would do this, and bam, alloc console function, Windows console, Microsoft Docs. If I'm not going to pretend like I've ever memorized this code, and so you can kind of see here that this is the way that you would figure out what to do it and how to do it. This doesn't actually give me an example. So the way I'm going to actually look this up is example, because it doesn't give me that. And notice it still doesn't give me any code. Never read that stuff. Always just find the, here you go. There it is. There's that same stuff I was writing, right? This is the way to do it, The only difference here is that you got the _W. That's because it's a wide string, and in modern versions of Windows, everything's a wide string. But here you can kind of see the way that you would figure out how a lot of this stuff works if you don't know it already. And if you don't even know what functions to look for, it's like create a console in Visual Studio. Create a new console, Visual Studio, WinMan. There's a reason I'm perseverating on this, because this is how you solve every problem in the world, from small to big. And you really shouldn't beat yourself up if you don't know a lot of this stuff off the top of your head. And so the key is you want to just kind of scroll down, find the first example that really makes sense, and you can kind of see it's starting to look correct here. you might find out like, oh, I want to use, this doesn't seem correct to me. This is still not right. So I'm going to go back, create a new console, Windows application. No. Let's call it open a console and win main. Bam. Here we go. This is not exactly what I'm doing. I'm actually the same. A la console, blah, 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 blah. Right? Don't get too wrapped up in the right way to do things. Just find a way to do it and then back into the right way over a long enough period of time. So sorry to perseverate on this, but I really highly recommend that. You'll notice that I have a couple of errors here. Text argument const char is incompatible with parameter const w char t. Why is that? Text is defined, in this case, as the wrong thing. You can kind of notice that this wants a wide string, right? W char. But text is not giving it a W char. So there's a couple options. You can either go L, and that'll work. Or notice that if I go here, it's looking for this Unicode, if-def Unicode. So one option is to go properties, C++, preprocessor, and I can add it here. And now you'll see it should resolve those errors. Or there's another way to do this, which I saw on a different project. You can actually, let's see. I don't know. My favorite is just the L. It's better. Text is a Windows defined thing, or you can do the text and define that Unicode thing. Either way. Cool. So we have to define both the standard input. We have to define the standard output. That's all right, because standard in, we're only reading. Standard out, we're writing as well. And we also want to define the standard error. Oops. And we're also writing to that, and it's the same as before. This should give us a console. So I have to put this now down here, otherwise it'll miss it. And now we've got my starting back. Great, awesome. So the next step is to create a Windows window. If any of you guys have ever wondered why Windows was called window, this is why. Because you make windows. It was always an old joke that one of the reasons that Windows was called Windows is because you take your computer and you throw it out the window. But the truth is not as interesting. So Windows has a bunch of different classes that define the particular window stuff. You know, like the title, the name, the stuff that the operating system is using. One of these classes is what's called the Windows Information Container, the Wind class X. You can kind of look at what is at definition here. This is the wide version of it, and so it's got the size, the style, the what's called the Windows process. Extras, the instance, the icon, the cursor, the background, the menu name, the class name. Great. So let's do a little bit of a hack here. Oops. By the way, if you don't know how to do the multi-cursor stuff. It's just Alt-Shift, and look at that beauty. Oops. Right. And now we can go thing by thing. So the size of the Windows class is size of Win class X. That's easy. The style we're going to define as 0. In fact, we don't really need to do this. What we can do is we can do the memset. There we go. One problem with having no things on your keyboard is that you can't see anything, especially the numbers. The numbers are the worst. So now I've set this to 0, and so I don't really have to set half of these because I can assume that the style is 0. I'm going to keep it commented out just so that you can see it. We're going to make this equal to the function winproc, which has been yet to be defined, which we'll deal with in just a minute. Actually, let's take a quick look at this guy. So this is a type winproc, which is this lResult callback. And what we can do is we can just copy this. And call this fwinproc. And now define this thing as you would imagine. You might not know what these functions do. If you really need to know, we can look it up in a minute. But actually it takes what's called the message, and then the W param, and the L param. And we'll leave this to do. Cool. So, and this has to return something. We should also provide this as a callback. This is a Windows specific thing. You can kind of see it doesn't really mean anything, but it's nice to have. So the extras are set to 0. The other extras are also set to 0. The H instance, gasp, is equal to our H instance. The icon, we're going to load an icon. You know, I don't really want to define an icon. So what happens if we don't define it? And the cursor is going to be the standard arrow cursor. The background, we're going to use this thing called Windows HBrush, which is effectively just a color. And then the menu name is going to be null, which is also not something we need to define because null is just 0. And then the class name is going to be our, OGL window. Great. Now let's just make sure that we're not missing anything. This is the class XW. We also have this, which we forgot to bring in there. Again, I'm not entirely sure if we really want to define it. So let's just do that. And let's see what happens. Well, nothing will happen because we haven't actually used it and we haven't registered it with Windows. So let's start off and try that. So if we try to register with the Windows that we just created, if this fails, what do we do? So let's create a breakpoint there. And also let's create a breakpoint here. So I want to kind of encourage you guys, especially when you do this, to actually follow along by debugging. So we're gonna, okay, let's allocate the console. Cool, now we've got a console. It's gonna print out the starting. Nice. So now it's gonna do all this stuff. It's gonna load the cursor. Now we have a WC Windows class that looks relatively correct, and we have a bunch of unused things, and let's see what happens. Will it succeed? It succeeded, but it didn't do anything because there's no other code. So it's gonna just give me back a pause. Great. Now what happens if it fails? Let's try to get this to fail. Let's not set this, for example. Whoops, I didn't set a breakpoint, and that's gonna not fail either because it doesn't really give a shit apparently about anything. Okay, let's try. You know what? I'm not even going to try to fail it, but let's assume it failed. What would we do? We would create a printf of some kind. We want to return fail. You know, all these bad things happen. This is something we can do. We can exit 0. Okay, how do we fail it? Let's fail this thing. I'm not sure how. Maybe we can add some stuff to the size. Will it fail? There we go. We failed it because we gave it a bad size. What it'll do, it'll give us a Windows registration failed, and it will quit. All right, that's a lot of code to do that, right? So I'm going to go a little bit off script here, and I'm going to introduce a new file that you may not. This is something that actually comes from my code, and I'm going to allow it. You know, I'll provide it to you guys to use as well. So this code is actually. Let me open it up here. This is EHM. Let me open it with Notepad. So the EHM, it stands for Error Handling Macros. And this is actually something that I got from my Microsoft days. And you don't have to understand this code at all. In fact, I don't recommend you try to. But I use this in almost every project since I left Microsoft. At the core of it, you have this thing called result. And actually, Windows uses something very similar called hresult. And you'll notice that the EHM does have specific Windows handlers for hresult, ch and chr, and so on, which I'll talk about what those mean. But for the most part, it's just a simple thing. Like you have some math defines, you have some of these, which are like different errors. Really, the key to this is that any value less than 0 in the result is an error. And what that means is it's very, very easy to check whether or not the result is a success or a fail. Because all you have to do is check that first bit of the value. And so if it's a 0, then it's a success. If it's a 1, then it's a failure because that's the sign bit of the value. And what's really nice about that is you can create these really complex and very sophisticated combinations of these functions to create one-line error handling. And what's really cool about this too is if you sort of nest these, you'll get almost like a stack of errors. That is really, really useful for logging. So you don't need to know too much about this. All you have to know is, no, I do not want to save that. All you have to know is that there are these 3 files that you have to put into your include folder. You can either add an include folder. So let me show you 2 different ways to include these files that I highly recommend you understand. One way is the sort of brute force way, which is, okay, I'm going to include, because my folder structure, if you take a look here, of course I closed that thing. Cool. my folder structure is such that my project is here, and then my include folder is here. So to access the include, I have to go one out, include, and now I have access to EHM. That's one way, which is really annoying. Another way is instead to go into C++, additional include directories, and then you add like the directory. Or you can do it this way, where you can go you can go like this. Great. And now it's right there at my top level, which is nice. So to use EHM, instead of using this rval, I'm going to do results r equals rk, or rpass, which is fine. Now instead of returning rval, I'm going to cast that result as an int. I'm also going to use this thing called label, which everybody's going to tell you a lot of shit that don't use gotos and whatever. I'm going to also agree with them. Do not use gotos unless you can avoid it. The EHM library is based on gotos, and the reason why will be apparent in a minute. But what's really nice about all this code now, instead of doing all this stuff, let's just make sure that including that folder builds. Looks good to me, and it runs. And the registration failed. Why did it fail? We'll find out in a minute. So instead of this, I'm going to instead wrap this in a CBRM. And you'll see what CBRM means. First, you add a condition. So I want register class X to succeed. So that's my condition. If that fails, then that sucks. The fail code, so the CBRM means that I can define a custom fail code. In this case, I want to pass a fail, the eFail as above, which if you want to know what that stands for, you can see Windows uses a very similar system to result. As you can see, 8, if you bring up 8, notice that the binary representation is 1000. So the first bit is 1. Cool. So the next thing I want is then the message. What is the message? It's just Windows registration failed. And then finally, if I have any arguments, I can pass them here. But I don't have to, because I don't have any arguments. You'll see this in later examples. And so what will happen here is, if I run this, well, it quit because there was no system pause as a result of error. Another nice thing about the EHM, it defines these other macros, which is debug line out, which I can say error. Error on exit. Okay. The Visual Studio is killing me today. Great. So now you'll notice some really cool stuff happened. Starting blah, 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 all this garbage. This is like a long line that'll tell you, oh wow, this file on line 47, the function winMain Windows registration failed. It's going to give you all that information just with that one line of code. So when it crashes, not only will you know, you'll also get the exact information of why, which is really, really helpful. It's a little bit more useful in many cases than just having Windows registration failed. And also, if you have a function that's wrapped in another function that's all calling this stuff, then it'll just kind of cascade, and then you'll have this like list of this happened, and this happened, this happened, this happened. You'll be able to kind of pinpoint where the error occurred. Let's get rid of that now. I want to make sure, good, we're good on time. Cool. So now we've registered the class, but it's failing. Why did it fail? Because we did this. Let's get rid of that. And now let's just make sure that our code still functions. It's always a good thing to have a sanity check. Well, there's no other code after that, so it's gonna, well, we'll know if, yeah, error on exit happens. Why? Because there it is. So it almost makes sense to have two. And this is just for kicks. It doesn't actually get used. But now, when we run this, great. We can put this up here. Not sure why it's trying to indent everything like crazy, but whatever. So, great. Okay, this is going to be a very inflammatory point in the class, so you don't have to do this stuff. You don't have to use the labels. It's up to you, totally. But I'm going to be using them relatively often. It just makes code take 10 times less time. Cool. So now, first we want to kind of add some style to the window that we're about to open up. So let's create the DWX style. And again, a lot of this stuff comes straight out of the documentation. So we want to have a window that's an app. We want it to have an edge. A lot of these things will be kind of funny sounding. Overlapped window. This is just kind of a core window style, like you want it to be overlapping with other things. It's pretty common. Rect_RC, so this is the rectangle that we're going to be using for the window itself, and we're going to define it as a 0, 0, 600, 600. If you really want, you can also be a little bit fancy with the syntax, and that's the starting point and the width and the height. You can kind of see the definition of rectangle is just a simple struct, left, top, right, bottom. Great. So now we're going to adjust the window to the correct size that we request. Just window rect x, and this is going to basically, according to the styles that we provided, adjust the rectangle. If you really want to see this in action, let's take a look. Right. So this is the only downside of using the EHM. You do have to kind of be worried about run style sort of initialization, or you can kind of put everything into another scope, which is actually what we'll do instead. No, this is all right. Let's just do it this way for now. Great. So right now our RC is 600, 600, and after we adjust, it is all sorts of wacky stuff. Cool. Looks like it's working. Now we need to create a window name. Let's call it OpenGL window. PC. And now we're going to create the window handler. just call it the handle to the window, and we're going to create the window. Now you'll notice there's a lot of stuff. So first we pass it that style that we had before. Then we pass it a class name, which we need to use the same one as before. But if this is the case, then what we should do is we should put this up here. And eventually, we can move all this stuff around into a struct as well, which we'll do in just a minute. And now instead of passing this as a value, we can do that instead. Now we pass in the window name and the DW Windows styles. And we add a couple as well. We want to clip the siblings, and we also want to clip the children's, and then we want to start it off at 800. This is the position, and we also want to have the width and the height. Although we could use the rect up there, but that's a different story. We have no parent. We have no menu. We have our instance from before, and then we are not passing any params. And that will give us a window. Now, what if this fails? We may never know. So let's kind of play that game a little bit. Right, so again, we have to deal with this. This is not an issue, generally speaking, is because you'll see EHM will kind of force you to design code the right way by putting a lot of this stuff into your class. But per the kind of example that we're giving here, it's not that important. One way to, by the way, bypass any of this stuff is to just do this, which is ugly, but it works. Oops, that's fine. Let's play that game. Kind of EHM forces you to scope things correctly. Okay, so to run it. Now, if it runs, great, nothing happened. But let's take a quick look and make sure that the window that we're getting is not null. Well, we're going to be out of scope now. So let's put this something like a equals 5, so we don't lose it. But it's null. Why is it null? That's no good. What is going wrong, and what are we missing? We are missing the resource file. And the resource file is, let's take a look at our code. It is in here. So if we take a quick look at it, we'll see that it's basically just a bunch of these guys. And it includes the icon.rc and the rit.ico. And what's the icon.rc, which I think is important to really quickly take a look at. You'll see it actually includes the actual icon itself. Should at least. There it is. There is the list. IDI icon, icon, RIT icon. Cool. So we could add the path again. So let's just do that. And let's do, oops, res. That's really all it is, right? If we look, it's the one folder down into res. Apply. And then in here, we can simply include resource.h. And now that should work. And now, if we go here, we'll find it. So let's see if that solved our problem. And now we're still null. So what's the story? Well, one thing we can do to kind of speed this up a little bit is we can just create, using the EHM, a CNM, which is going to allow us to really kind of check whether or not this is failed to initialize or not by creating a check on the null. So just passing this will allow us to see that. And now if I run this, it'll tell me the window creation has failed here, although it won't tell me why, which is not exactly the best situation. Right? Okay. So here is the problem. Why is this failing? Sucks. Well, one thing that the create window tries to do is it actually tries to hit this function here, which is a problem. You'll notice if I set a breakpoint here, I'll hit it. And I'll hit it only after I hit the create window. Boom. And that's a problem. It's going to try to hit it a bunch of times. Because when you create a window, a bunch of events occur, and that's exactly what the Windows process does. And so what we're going to do now is we're going to have to fill in the Windows process just a little bit and make sure that we actually do something with it. So, we're going to start off filling it out with kind of the that design below. And this is where a lot of the stuff that your window is going to do, this is kind of where it happens. These are all the callbacks for the Windows API. And so the way you deal with it is, at minimum, you have to deal with this one, which is return def window proc, which is the return the default Windows process. So if you say you get a message from Windows and you don't actually need it, you just return. And so if I add simply this, then now we will not get a null. And the window creation was a success. So let's really quickly talk a little bit about the Windows process and fill this out, because obviously we don't want to just return the default Windows process every single time. And so let's add handling for the message. And so the message is in the format of this int. And there's a bunch of different messages that Windows can provide us with. So let's start off with a switch statement that's going to handle those for us. So let's start off with the default. If we're not going to handle anything, and this is, by the way, my kind of personal way to do switch statements. A lot of you may not know, you can put in curly braces pretty much anywhere, and this is really nice, especially when switch statements kind of get a little bit out of hand. But let me just take this and put it in there. And actually, let's experiment with this a little bit and see what happens when I do that. So it's going to hit that down there, and then it's going to hit here. So let's take a look at what that message looks like. Message 36. Wow. Not really sure what that means. Okay. So how about we add one of the messages that I know about. This is the close message. So this is the message that your window is going to get if Windows is looking to close you. And you can call this function, and you can also do a few other things. But what's nice about this, if you know one message, then you can hit define on it, and you can see all the messages, right? And what's 34 in machine speak? Let's see. In hexadecimal, that's decimal 52. Oop, actually, what was 34 in the other way around? 22. So let's find 22. Where's 22? There it is. Child activates. Which makes sense, right? Because a top-level window is creating a child window. And so, cool. Let's add a couple other ones. Case WM destroy is another one that you need to support, which is the underlying operating system telling you, hey, we want you to shut down. And this one will come into play later, but we can actually get an event that says there's a key down message. And this one is provided in the W param. So the W param will give you the value. So say I want A. Actually, we can do it either here or on the other side, but that's up to you. You know, then I can say debug line out. Hey, great. Else, if W param is equal to 27, which is the escape key, we can quit. Which won't mean anything yet because we are quitting anyways. And in fact, we won't even have a chance to run it. Like, let's try it. Okay. Hey, oh. I can't really do it. Anyways. However, if, let's kind of cheat a little bit. Will it work? If I do a thing, it's just running forever. Doesn't look like it. You know why? Because we're not actually getting those messages from Windows yet. We'll talk a little bit about what that means and how to actually make that happen. Right now, even though our Windows process is live and it's getting messages from the underlying operating system, we're not actually what's called pumping the message pumping the message pumping the, I don't know, the event queue, whatever it's called, I forget. But yeah, in short, we're not actually driving those messages. So let's move on. We've got our window, but we don't actually see anything. So all we have to do now, and this is kind of the end of the Windows specific code, we want to just show the window. And again, the command show is a variable that we get from the underlying operating system when you run for the first time. And then we also want to update the window for the first time. And that's kind of it. And this should create a window. Neat. But it doesn't do anything because we created the window and then the program exited. All right. So that's sort of the end of part one of this. The second part, I'm going to keep going. I'm going to do the whole thing. So just so you know, the second part of this is more to do... Actually, no. I'm going to stop it here, and then I'm going to kick off the OpenGL stuff for next week. I believe that is the right way to split these two apart, because this is quite a long one otherwise. Great. So now you know how to at least kind of rev up a window and get it up and running. And yeah, if you have any questions about any of this, I might actually just post everything unedited so you can kind of see how I struggled through some of the issues here as well. And I hope this is helpful. Feel free to watch this at 2 times speed, especially for the parts where I'm kind of tripping over myself. But yeah, if you have any other questions about this stuff, let me know. And the next time we're going to pick up here in OpenGL land and start to get that up and going. Awesome. See ya mañanas.